Good morning, everyone. So, we have successfully completed 12-week interaction sessions on design of steel structure, where we have specifically went through the concepts of each topic regarding that particular week. Then we solved the previous year, that means 2020 assignments, along with the different numerical problems, so that the concepts and the problem solving abilities regarding that particular week will be developed. So today, this extra session, I planned it for if there are any kind of questions regarding the final exam, and as well as to solve some assignments of 2022. Although all the assignments are similar in pattern, but there are some a little tweak and twist here. So let's quickly solve some of the week's assignments of 2022. Then if there are any questions regarding any of the topic or any of the week's assignments, then feel free and you can ask me, or you can reach out to me by my mail ID. So my name is Devashish Panda. I'm a doctoral student and research Prime Minister Research Fellow at IIT Guwahati. Okay, so um, let's quickly went through some of the assignments of 2022. Then I will take up the questions if you have. So Teja, am I audible? Can you confirm? Am I audible? Are you there? Okay, so meanwhile, you people will join. So let's quickly start, discussing about some of the assignments problem, and I will upload this video as well as the material uh, to the drive folder so that you can access. So let's quickly solve some of the assignments of 2020. So if you solve actually 22 and 20 assignments, the exam, the question pattern of the final exam will be similar kind of that assignments. Only there will be some change in values, all these things. So let's quickly solve some of the questions of 2022. Then I'll take up the questions. Okay. So if you have, Teja, any kind of questions, then you can write it down in the chat box. Okay. So what is the first question? It is regarding the percentage of carbon in steel. Okay. So regarding the percentage of carbon in steel, we went through detail. We went through different kind of steels containing different kind of carbon content. So you have a dedicated table for it in week number 1. So I will suggest please go through it. So generally what happened, uh, incorporating the carbon content to the steel. So if we increase the carbon content, what will happen? The strength of the steel will increase, but at the same time, the ductile property of the steel will decrease. So we need to maintain, some level of carbon content so that the desired strength and ductility both can be achieved at the same time. So generally, the percentage of carbon in steel will vary from 0.2 to 2%. And in week 1 uh, assignments, there is a particular table where this kind of details are provided. So I will suggest please go through that table also. Maybe MCQ type questions may come from there. Okay, so now let's move to next question. So it's question number 2. It's regarding the yield strength, the relation between the yield strength, diameter of the grain size, and some constant. That means in a grain level, how we can correlate the values of yield strength. Okay, so basically there is a formula or relation. You can get it in. Sir, can we get PDF of this after media? Obviously, I will share that entire 2022 assignments with you, along with the video lectures. You will get it from my YouTube channel, and I will upload that on that, drive folder. You just go there and you can find it out. So my motto was that particularly that you should expose some of the questions so that your confidence level will boost. And and, and my suggestion is like, the questions whatever we have solved in 2022 2023, if you solve them carefully, then I can tell you that more than 95% of the questions you can attempt. Just there will be some little bit of change in values and all these things. You can see, like, you have solved 2023 and 2022 questions. So now here is the 2020 assignment sets. So you can, when we will go through some of the weeks assignments, you can understand that, yeah, the question patterns are similar. So where we need to focus, and how we can manage the exams and all these things. So here what I'm saying, that what I was saying, that relation between the yield strength and grain size, that is defined by Fy. That means first we need to know at the crystal level F, that F0, that means the yield strength of very large isolated crystal, plus that constant upon root D. And here that D, you need to put it in millimeter. So try to remember that formula also. If the question comes, then you can attend it. So C will be the correct answer. So let's move to the next question. So let's quickly solve this particular week, then we will take up the question if you have any. Okay. So let's move to the next question. Which of these falls under the limit state of serviceability? Okay. So we went through the details of the limit state, where we have seen that we have two kind of limit state. One is a limit state of strength, and one is limit state of serviceability. That means one limit state deals with the safety purposes, and one limit state which deals with the serviceability purposes. So which of these under the serviceability? And what do we mean by serviceability? That means that condition will satisfy the comfortness of the occupancy, or the comfortness of, or the purpose of the structure for which we are making. Okay, so here we can say that durability comes under the serviceable limit state, and fracture and stability, overturning, that's all are comes under limit state of strength. Okay, so that's all. Now move to next question. Okay, this is regarding the load factor of safety of limit state. Okay, so here for this load, what will be the factor of safety corresponding to different kind of load cases. We have a dedicated table in our code IS 800 2007, and that is the table 4. So, and I will suggest you and also recommend you, please try to remember the factors, like for dead load, dead load, live load, crane load condition. 1 mark question may come. Although if any of the question will not come from there, but still these factor of safeties will required when you perform some design or analysis on the later weekend. So this table, like, two or three things like dead load, live load, and crane load combination, dead load, live load combination, and dead load, wind load or erection load combination. These things you should keep in mind. Maybe 1 marks question may come from there. So the question was, what was the question here? What is the appropriate load combination for dead load, live load, and accidental load? So obviously it is 1.35 and 1. And if dead load and live load, there should be different kind of combination. So here you can see dead load, live load, and accidental load combination 1.35 and 1. So that thing you should keep in mind during the examinations. Okay, now here one question is there regarding the modulus of elasticity of a material. So what do we mean by say modulus of elasticity? Here the question says, consider the statements of question 6. So we don't need the question 6 statement. Here the proportional limit is given, stress within the proportional limit is given, stress within the proportional limit is given, and the corresponding strain is also given, right? Calculate the modulus of elasticity. So first tell me, what do you mean by say modulus of elasticity? It is the ratio of, so if we draw the stress strain diagram of a particular material, say let's say for a mild steel, and we are interested up to the zone of the proportionality limit, that means up to the limit up to which the strain is directly proportional to strain. That means up to the zone where the material will behave linearly, or we can say up to the point up to which the material will follow the Hooke's law. So modulus of elasticity, we can say it's the ratio of normal stress, normal, okay, not shear. We have two kind of stresses. We have discussed it in details. So in case of shear, that will become the shear modulus, but in case of normal stress upon normal strain. So here the stress value is given to 20 divided by the value of strain 0.12%, that means 0.0012. So that will comes as 1.8 into 10 to the power 5. And one more thing, please remember about the zones. Like this is the proportional limit, then we will have some elastic limit, then upper yield point, lower yield point, fracture, ultimate strength, necking and fracture. Please remember these zones. Maybe one mark question may come from these zones. Like they will mark the zone and will ask what is the zone corresponding to that stress strain curve. Okay. Now let's move to the next question. What next question says? It's again from the load combination. Look, here the load combination of dead load and live load. So for dead load and live load and under the limit state of serviceability. So please check the table which kind of conditions you are taking or looking for. Like if you are looking for limit state of strength, then the sort of partial safety factors for that particular load combination will be different. So here for limit serviceable limit state, we all use that of 1 and 1 for the dead load and live load combination. Now the size of diameter, the size of the rebate is defined by, okay, the size and bolt both are defined by the diameter of the shank, right? So we have went through it, diameter of the shank, because you know remember that thing, that bolt we have two parts. One, the unthreaded part, whom we call shank, and the diameter of shank, that is considered as the diameter of the nominal diameter of the bolt. And for the rivet also, the diameter of the shank is considered the diameter or the size of the rivet. Okay, so let's quickly go through some of the other concepts of rivets, like what should be the gross diameter or the hole diameter. Like in bolt we have a dedicated table number 19 for calculating the hole diameter depending on different kind of slot size. But for the rivets, you need to remember that as per clause 8.9.3 of your IS 800 1990 1984, because 2007 doesn't include the riveted part. So here these two things are important regarding to your exam. Like what should be the diameter of bolt hole if the diameter of rivet is given like that. Okay, so here what is saying, that if the diameter of rivet is less than 25 mm, then the diameter of rivet hole should be nominal diameter of the rivet. That means the diameter of the shank of the rivet plus 1.5. And if the diameter is more than 25 mm, then the additional value will be 2. Like in bolt, for the bolts we have a dedicated table number 19. From there we can get the data depending on the diameter of bolt and the nature of the slots. So these two things please remember. Like if the diameter of rivet is given or the shank diameter of rivet is given, now they will ask what should be the gross diameter or the diameter of the bolt hole, a rivet hole. So you can find it out from like this. So we have solved this kind of problems in the current weekends. Like 2022 we have encountered this kind of problems, and uh, in 2023 also there was same kind of problems. Okay, now one more thing, like here the next question says what should be the diameter of bolt hole. What are you saying, that for the bolts we have a dedicated table number 19 and the diameter. And please remember, try to remember the slot size with respect to standard clearance, because most of the cases the standard clearance, because we are dealing with the bearing type of bolts, so most of the cases the standard clearance will follow. So generally uh, up to 14 mm or 12 to 14 mm, the standard clearance is 1, and 16 to 22 or even 24 mm, the standard clearance is 2. Okay, so if the diameter of bolt, like here the diameter of bolt is given like 16 mm, what should be the diameter of bolt hole? So you need to consider the standard clearance. Okay, if the clearance is specified, like you need to go for oversize or slot size, then you need to look for another value. So I think they will not go there, because for that you will need the table. But for the standard clearance, you can easily remember that 16 to 24 mm bolts, you just need to add 2 mm standard clearance, and 12 to 14 mm bolts 1 mm, and larger than that you need to add 3 mm. Okay, now say move to the next question here. Okay, so here this is regarding the shear failure of a bolted joint. So these things also we have discussed, like so let's quickly went through that concepts also little bit. So like this is we are dealing with the bearing type of bolts. That means this connection will subjected to slip, because in a bearing type of bolts we have learned that the tightening condition we maintain is the snug tight condition. SNUG, snug tight condition. That means the condition of tightening up to which the member which we are trying to connect, they will firmly join. Okay, that means we are not introducing any kind of additional tension to the bolt. So here you can see, if so what will happen when we apply the load here on both the faces? What will happen? Slip will occur, and the that plate will come in contact with the bolt two sides. That means in that two sides that bearing thing will occur, and along this plane, if you look uh, that cross section of the bolt along this plane, while what we will see, that the induced stresses are transverse in nature along the stress. This is the cross section of bolt along this plane. So what will happen? The shear stress will generate through that plane, particular plane, and if the generated shear capacity, generated shear stress or generated shear force value is more than the shear capacity of the bolt, then that will fail in shear along this plane. So this plane we call the shear plane. Shear plane. So here you can see how many shear planes are there. Only one shear plane are there. So let's say we have a connection like this, where we need to join three plates, or we have a double cover bar joint. There is also uh, different kind of shear planes can be there. So take for example, we have three plates. Now we have one bolt there. So and I am applying the same directional loads. So tell me, what will be the number of shear planes? Because these shear planes we need to consider while calculating the shear strength of bolt also. So obviously here we can see that there are two shear planes. One is along here and one here. So shear planes are decided based on and that particular connections. So here you can see, here we have two shear planes, so we call this is a double shear, or the bolt is in double shear. And if there are triple shear planes, or there can be multiple shear planes also. So by this way we can identify that a particular joint is subjected to a single shear, double shear, multiple shear, and accordingly we can calculate that VDSB, the shear capacity of that particular bolt. Now, what the next question says, what you are saying, that yeah, similar kind of questions are there, but there may be some difference in values and all these things. So this question number 14, in a bolted connection, the reduction in area due to the bolt hole can be minimized by arranging. This question we have solved during 2022 also. So how we can minimize the area? By providing the bolts in a zigzag manner, right? So here let's quickly spend 1 or 2 minutes here. So let's say we have two plates. I will explain the stress, that distribution with respect to that reduction of area. Say for example, we have two cases. Say we have lap joint, and we have two rows of bolting. Okay, so same kind of that joint. Okay, So say for example, this plate is above it and this plate is below it, and we are applying load here. So we are seeing the plan view, that means the top view. So actually what will happen during the load transformation or the stress transformation, and why we will or we should prefer, if that provision or that privilege is in our hand, then we will go for that zigzag or specifically diamond. Why? So let's, for example, we need to provide 2 or 3 rows of bolting. Say in a chain bolting we are providing say 9 number of bolts, 3 in each column. Now same arrangement we are making here, like 1, 3, and symmetrically on the other side. Okay, so here 9 bolts we have arranged in figure number 1, we have arranged in a chain bolting. Yeah, we can do it if we provide that the pitch and edge distance as per our clause, then yeah, we can go with the chain bolting. Now what will happen when the load and stress will transfer? So what will happen, like we are applying the load here, so these parts, so that stress will transfer from these to these, local transformation and stress will occur, and these zones will be the most stressed zone here and here also, the symmetric portions. Now first, this portion or this section 1 1 will subjected to the stress transformation. Now you can see the cross sectional area of the 1 1 is reduced. If we calculate the n of these, so we can see that b minus n d naught will be, or into t will be the cross sectional area of this thing. So this portion will be the most stress portion, because suddenly the area is reduced more. Now in this case you can see that when the stress will transform, what will happen? First, in 1 1 section there will be the large cross sectional area, because one bolt is there. The arrangement will be such that, yeah, first bolt will subjected to, or placed where the maximum cross sectional area can be achieved. So here you can see that overall arrangement, the overall reduction in cross sectional area plus better strength and better safety corresponding to if failure occurs, then obviously then here the stresses will transfer, then subsequently the stress will go from here to here, and when it will reach up to the middle, the stress almost more than 60% of the stress will be transferred from this plate to this plate. So there in the middle portion, if the area is reduced little bit, so there will that will not create that much of problem. So this is the concept of going to diamond bolting instead of chain bolting, if we have that privilege to provide that kind of bolting for that particular situation and for the particular joints. Okay, now let's see the next question. Here the center to center distance, these are the distances of bolted joints, so I will not spend time. So let's quickly go through some of this. So if I have, yeah, this drawing you can see, so if I have a connection and the arrangements also, so we have certain distances, like, so we need to first define them. Like here we can see there is a center to center distance between two consecutive bolts, which is measured along the direction of application of load or direction of application of stress. So here we have one distance, the distance of the center of two consecutive bolts measured along the direction of applied load. This distance we call the pitch distance, and the distance here you can see the distance which is perpendicular to the application of load, because the application of load is in that direction, so this we call the gauge distance. So we have, and two more distances will be there, like end distance and edge distance. End distance is the center of the last bolt to the adjacent edge of the plate measured along the direction of application of load, and for edge distances it will be the perpendicular distance. So uh, regarding this particular topic, you should keep in mind the minimum values, the maximum values of these distances. Like for the pitch distance, clause 10.2.2 says that we need to provide minimum of 2.5 d as a pitch distance. Like for age and end distances we have, like 1.5 d naught if we are uh, drilling that hole in factory, and 1.7 d naught if we are drilling that holes at on site d naught. So these things you should keep in mind. Maybe 1 or 2 marks question may come from this thing. Okay. So these are all given here, so I will not go in detail. These are the basic thing. Okay, this is the sorry to disturb you. There are any weightage of marks for all? Okay, 1 second. Okay, Sivraj, what you have asked that, sir, is there any weightage of marks for week of all week contain the same marks? Um, Okay, actually, the weekly assignment marks is the matrix of that marks is like, you have 12 assignments, and out of that 12, the best of 8 will be considered for evaluation, and 25% of the total marks will come from that total marks of the assignments. So, clear that thing, or you have still any questions? Yeah, final exam. What final exam? No, it's like, okay, okay, I get it, get it. You are particularly asking that, from a particular week, there can be, some more questions or less questions, and that will depend entirely on the, SME of that particular course. So you have to you have to go through all of the questions. But in general, from each of the assignments, there should be equal number of questions. Now there should be 10 or 20% deviation, that the who is setting the paper, that privilege he or she had. Okay, so particularly the rule is, uh, the same amount of the same number of questions should come from each of the weeks. Okay, like if I want to set, like, in final exam you will have more than 60 questions. Out of that, I think 40 or 41 questions will be MCQ type. So obviously they will cover that MCQ portion, most of the MCQ portion from that particular week. But each of the week will contain, you know similar or say same amount of, or same number of questions, not the amount of, same number of questions. Okay, so I will suggest that please go through each of them. Okay, like, mm, that's all. That number should be same from that. That is the standard procedure. Now there should be 10 to 20% deviation. Clear what you were asking? Sivraj, are you there? And is your confusion clear, or still there is any questions? You can ask me, no problem. This session is particularly to discuss the, sir, 40 questions MCQ. Then what about the 20? That means, yeah, actually, you know, you didn't got that exam instruction, so I will suggest that go through that exam instruction. Okay, like, there will be MCQ type, MSQ type, numerical type question. Like, there will be 1 mark question, there will be 2 marks question, and there will be 3 or 4 marks question. So first, MCQ type question will contain one, MSQ type question may contain 2 marks, and the numerical type questions means, you will ask to put some values. So there should be a standard deviation of that. Like, if I explain it to you, like what kind of questions I am talking about. 1 second. Yeah, like for example, here the question. this is a MCQ type question. Now, if this question is projected in a numerical type format, so where be careful about entering the answers, because this is also important. Like for this question about the correction factor, right? So now, if the question is asked like that, what will be the reduction factor? This, and the value is given like this dash. You need to enter the answer. So here, the value comes as 0.985. So generally, some standard deviation is provided there, that the answer of like 0.9, say 98, so 0.90 to 0.99 will be accepted, or there may be more standard deviation. So be precise, read the instruction carefully, up to which decimal places you need to consider, then put it there. Okay. So there will be 1 marks question, 2 marks question, and three maybe 4 marks questions are there. So three up, beyond three we generally don't go. So that's, so first try to solve that for assignments, that MCQ questions, that like rapid fire type questions, you can solve it easily. And that questions particularly from each and every weekend, that question will come. And if you solve 2020, 2023, and that 2020, you will get most of the MC questions from there, most of the 99% of the questions from there. Okay, so don't worry about it. Okay, still, do you have any kind of questions, or we can solve some of the problems, then we can close the session? Sivraj, clear? Three assignments like 22, 23, and the 20. Go through it. Don't worry, you will or you can solve all the questions of final exam. Okay, so here we are talking about the that correction factors, uh, or the correction factors we have introduced during the calculation of that shear capacity of board. So particularly we have three kind of correction factor as per our code, like beta Lj for long joints, beta Lg for large grips, and beta Pk for the packing plates. So these correction factors are introduced, to reduce the shear capacity of the bolts. That means if this type of condition, some of the conditions are there, some of the, if that conditions come for that particular, connections, then this kind of uh, correction factors should be introduced. So beta Lj, this is the correction factor for long joints, and this is for large grip, and this is for packing plates. So let's quickly go through that in a minute. So first, the correction factor regarding long joints. The questions that question was asking that what should be the value of the correction factor regarding these long joints. Okay, so here clause 10.3.3, or you can remember that if if the, when we can introduce this, if the length of the joint Lj, length of the joint is more than 15 times the diameter of the bolt, then we need to introduce that beta Lj. And how we can calculate the beta Lj value? Here the formula is given, that you need to consider 1.7 1.075 minus 0.005 Lj by D. And the beta Lj value, this has the upper bound and lower bound as per our code. Like the value of the lower value of the beta Lj is 0.75, and the value should not be more than your 1. So this is for long joints. Another, this is Lg at the next clause 10.3.3.2. There, like if we have that larger grip length, that means we need to add more than 2-3 plates, then we may have a larger grip length. Okay, so if that grip length, how we can calculate the grip length? Just sum of the thickness of the plate And how we can calculate the uh, joint length of the joint? Here, this is the length of the joint. You need to add the pitch distances and end distances. Here you can see this is the length of the joint for a particular connection. And grip length, this is the grip length. You just need to add the thickness of the plates or the members which are there within the connection, right? So if that grip length, here the code says if the grip length, that LG, is more than 5 times of the diameter of the bolt, then we need to introduce that beta LJ. That means it's also a reduction factor or correction factor. So how we can calculate the value? 8 by 3 plus Lg by D. So if the value of Lg, that means grip length, diameter of bolt, and for the case of that joint length or the connection length is given, then you can easily calculate the value of the correction factor. And one more correction factor is there for packing plates. Like I have already told you that packing plates are generally provided to make the connection happen. Here you can see if we need to make a double cover butt joint between, say for example, this is a plate of 15 mm and this is a plate of 20 mm. So it is not possible to make a double cover butt joint without a packing plate. That means we need to add a packing plate of 5 mm. But this packing plate doesn't contribute anything towards the load, you know, distribution or load transferring mechanism. So during the design purpose, we will not consider any kind of strength from there. Although if the thickness of the packing plate, that thickness of the packing plate we need to provide, if the thickness is more than 6 mm, we need to introduce one correction factor. And the correction factor can be calculated using this formula, like beta pk is equals to 1 minus 0.0125 of tpk. Okay, so what is that tpk? This is the thickness of the packing plate. And now move to the next question. What next question says? It's about the partial safety factors of the materials, and the partial safety factor of the materials are given in table number 5. So this table number 5, which safety factors are important here? The important safety factors, like the safety factors with respect to, when we need to consider the gross cross sectional failure, then 1.1 for bolts, 1.25, and particularly for the rivets and welds. Here for the shop and for the field fabrication, the values are given. So basically you need to remember for the weld, if shop fabricated 1.25, if field fabricated 1.5, for the bolts for all cases it's 1.25, and for the material 1.1. Simple three things you need to remember, and I will suggest please keep in mind, like simple thing for the material 1.1, for the bolts for all the cases 1.25, for the weld if it is shop weld 1.25, it field fabricated, then go for 1.5. Like now two plates of, now this question is from weld connection. What should be the maximum size of the weld? Here two plates. So recall, we went through the details of how we can fix the minimum and maximum size of the weld. So tell me, the minimum size of the weld should be specified by for two cases, if we have plate to plate connection and if we have plate to angle connection. So let's quickly go through that concepts, like what should be the size of the well, whom we call the size of the well. The size of the well should be specified by the leg length, and whom we call the leg length. The leg length is nothing but the distance from the root to toe on the each side, this leg length. Now how we can specify the leg length? First we need to understand or specify the minimum size of the weld. So the minimum size of the weld will depend upon the maximum thickness of the plate. Like we have here two plates. Say for example, we have 20 mm plate and we have say 15 mm or 10 mm plate. So this is say 20 mm plate and this is say 10 mm plate. So I need to decide, or we need to decide the size of the weld, or the size which we should specify for this particular connection. So how we can find it out? So first thing we need to look for what should be the minimum size. So the minimum size of the first run should be depend on the maximum size of the run. Like up to 10 mm it's 10, you know, over 10 mm it's 20, and all these things. 20 mm it's 32 mm, and all these things. And this was the minimum size. And the maximum size, how we can specify it? So code says we have two conditions. If we have, you know, plate to plate connection and plate to angle connection, we have two kind of things. So if we have, you know, plate to plate connections, we have discussed these things. So plate to plate connections, the maximum size of the weld should be the thickness of thinner plate. Okay, the maximum size of the weld depend on the thickness of thinner plate, but minimum size of the weld is depend on the thickness of thicker plate. So for the plate, clause 10.5.2.1, that says the maximum size should be thickness of thinner plate minus 1.5. And if we have a arrangement like this, we need to, you know, make a connection between a plate and angle section, then the thickness of the size of the fillet weld should be the 3/4 of the nominal thickness of the angle. Like nominal thickness of the angle, like if this is ISA, Indian Standard Angle Section of 100 mm into say unequal angle section, say let's say 75 mm into 10 mm. So that 10 mm is the nominal diameter and nominal thickness of the angle section. So if we have plate to plate connection, the maximum size of the weld should be thickness of thinner plate minus 1.5. And if this angle to you know, you need to connect a plate to an angle, and the welding is done on the toe or any side of this angle section, then the maximum size of the weld should be 3/4 of the angle section. So what was our question here? That was the connection between plates. Like one more thing, this part you can remember. Like if we have deep penetrated weld, like if that fusion zone will, you know, penetrate like this up to wind up to this, for these cases, like one a twisted question may ask, if there are deep penetrated weld, then the maximum size, what should be the maximum size? Then the maximum size should be, you know, size of the minimum leg length plus 2.4 mm. That 2.4 you need to add if the in a particular question that deep penetrated weld is mentioned. Okay, so you know, like submerged arc welding. For submerged arc welding, yeah, this is a one kind of, you know, that deep penetrated weld. So for this kind of question, like they have asked, if they ask that there are a submerged arc welding type weld, and what should be the minimum leg size? So you need to calculate that thickness of thinner plate minus 1.5, then you need to add 2.4 with that to, you know, incorporate that deep penetration towards the root. Clear? Okay. So what was our question? Let's quickly look and solve it. So here two plates. Read the question carefully. Two plates are there. We need to calculate the maximum size of the weld. So how we can calculate it? It's two plates. So which is the minimum out of them? It's 10 mm plate is the minimum out of them. So what should be the maximum size? It's nothing but 10 minus 1.5. That means 8.5. So 8.5 is the right answer. Clear? Okay. Now let's quickly go through some of them. Like throat thickness. What do you mean by say throat thickness? It is the you know, effective throat thickness is the perpendicular distance from the root to hypotenuse of the you know, fillet weld, like here to here, and the effective area of the weld is specified by the, or specifically for fillet welds is specified by the throat thickness, and the throat thickness will depend upon the fusion phases, like this table number 22. If someone asks that what should be the value of k, or they will not ask like this, what should be the, you know, throat thickness if the angle of fusion phase is like 120 degree, and say size of the weld is given 5 mm. Now calculate it. So you need this table. So if these values are not provided, so you need to remember, like 60 to 90 0.7, 90 to 100 0.65, and so on. Point 0.5, point 0.5, point 0.5 is reducing. So this table is also important. One mark will definitely come from this question, like what should be the value of K, what should be the value of TS. Like I am asking TS, what should be the value of TS for 120-degree fusion angle and 5 mm size, what should be that? So you need to first find out what should be that K factor value and then size of the weld. So for this the K value is 0.5, so 0.5 multiplied by 5, so 2.5 mm. So likewise 1 or 2 marks question can be settled from this kind of particular topics. Okay, so now this is like end returns. Yes, end return and overlap length, these two clause are also important for the numerical purpose also. Although if you know this question may not come or may come for these exams, but these are important for each and every competitive examinations. Like what should be the effective length? What do we know? That effective length up to the length, you know up to which we maintain that proper throat thickness. That means we maintain the proper cross-sectional area of the weld up to that portion, so that the desired strength, whatever we have assumed or we required for the design purpose, that strength can be achieved through that length. So actually overall length, the effective length portion is exclude the end return portion. Now overall length will be for each you know termination. We need to provide a end return of 2s, 2 into size of the weld, 2s. And why we need that? This is required to for quality termination, and if there are any kind of stress residual occur, that can be uh, minimized by this length. So effective length LE, if actual length is given for a question, say actual length of the weld is given, actual length of the weld. Now you need to calculate the effective length and the arrangement is given. So what would be the effective length? Actual length minus the end return 2s. If there are one end return, so you need to multiply 1. If there are multiple end returns, then you need to multiply it with the same number of multiplications. Okay, now effective length and overall length. What should be the overall length? Overall length means the length you need to provide on actual connections, like you need to provide on the side. So overall length should be effective length plus the end return portion. And clause says the effective length of a weld, that means particularly for a fillet weld, that should not be less than 4 times of the size of the weld. Okay, that's all. And for the lap cases, like in a bolted case, we don't have any kind of upper limit or lower limit of the lap length. But here for the weld connection, for the warping effect or stress residual, to minimize that kind of phenomena, so the code has limited the lap length, overlap length, right? So the overlap length, here the clause 10.5.3.1, this is also important clause. The overlap of lap joint should not be less than 4 times the thickness of the thinner plate or 40 mm. That means that lap length, that means the overlap length or minimum overlap length should be maximum of 40 or 40 mm. So one or two questions can be settled from these particular topics. I'm particularly talking about the MCQ and MSQ parts. Okay, the numerical parts, you have different kind of questions like that, and most of the questions that first 2 and 3 weeks, if you solve this, that you can see, yeah, most of the 1 marks question will come from the like bolted, welded, tension member and compression member, this kind of things. Now let's see what is next. It's the design strength. So design strength per, if we need to calculate per mm square, then we just need that portion only. And if we know that per mm square, per square of length, area of length, then we just multiply the area. So here what is that? That is the effective area of the weld. What is that? That is the ultimate strength of the deposit material or pellet material, whichever is more, then this is the partial safety factor. So by this way you can calculate the design strength. So this formula is also important, like per meter or per mm square. If you need to calculate this strength, then just if you have the ultimate strength by root 3 into gamma m naught. And if you need to calculate it with respect to per meter, that means per length, then you just need to calculate lw, then per area tt. By this way you can manage these things. Okay. Now, like this question, read the question. If the size of the fillet weld is 5 and the fusion angle is 90 degree, what should be the minimum end return provided? Tell me. The question, the values, like the size of the fillet weld is required, but the fusion phase will not required, because the question asks how much end return should we provide, and for each termination we need to provide the end return of 2 into s, only the size of the wheel. That means 2 into 5, 10. 10 is enough. So read the question carefully, which or what outcome they want. What should be the value of k? Calculating the throat thickness, like this: 104. For 104, it's zero point 0.6, and 120, it's zero point 0.5. So these values you should keep in mind. Okay, one question, 1 marks question may come from there. Okay, calculate the effective length of the fillet weld if the overall length is provided, like this. What am I saying? That's why I have particularly discussed that topics. Like here, the overall length is provided, size of the weld is provided. Now calculate the effective length. What is the effective length? What I said, what is the effective length, or how we can calculate the effective length? It's overall length minus the end return. That means L effective of the weld should be calculated L overall minus 2s. So here the overall length is given 1200 minus 2 into the size of the weld is given 6. So that means 1188 mm. It's a simple question, but this thing you should remember, and the most importantly, that thing should come to your mind immediately during that examination. That thing is most important. And the catching power, yeah, the question is like that, so I need to solve the question like this and these things. And don't be nervous, be confident and solve the questions. There will be very easy questions. If what I said, if you solve the assignments of 2020 to 23, that means the current week, and whatever we have solved during that 12th week 2022 and this 20, all of the questions you can attend. Like there are similar kind of questions, like you can see, there are similar kind of questions, data are different, or there are some little tweak and twist are there. That's all. Like the efficiency of welded joint is, tell me, what is the answer? Efficiency of welded joint is more than your bolted and riveted joint, because let's consider one butt joint of weld, and say for example butt joint of your bolted connection. So here for the weld case, say for example we are providing, say, complete penetrated U or V butt weld. Okay. So say for example, if this plate is made of with Fe410 and this is also Fe410, and if the deposit material is more than your Fe410 or Fe410, then what actually we have done to that two plates, we make a solid compact plate. That means theoretically, with the welded connection or welded joint, theoretically we can achieve 100% of the strength. And how we can calculate the efficiency of the joint? Efficiency of the joint is the strength of the solid plate, strength of the solid plate. That means how we can calculate the strength of the solid plate? TDG is equals to AgFy by gamma m naught. So we have solved this. Clause 6.2 of your ICE 800 provides this value, divided by strength of the joint. strength of the joint multiplied by 100. Now here you can see strength of the solid plate will be same for all, but the strength of the joint in case of weld, theoretically we can achieve 100%, right? One in one. But for the case of bolt, we have seen that we need to provide the bolt hole to accommodate the bolts. So obviously what we have done to that plates, that we reduce the cross sectional area of the plate, right? So cross sectional area have reduced, that means the strength of the joint is subsequently reduced, right? Because the strength, how we can calculate the strength of the joint, how we can calculate the strength of the joint, the strength of the joint should be minimum of, if it is bolted connection, minimum of strength of bolt VB and strength of the plate at rupture of critical section, or we can say strength of the plate. But we have seen that the rupture strength is less than your TDG. So by this way you can calculate the strength of the joint. That means theoretically, yeah, for the welded joint we can, or we may achieve the 100% efficiency. Okay, so here like one questions may come from here, that some values of bolt is given. Now find out the efficiency of the joint, or find out the maximum load that can be transferred safely from this joint or through this joint. So maximum amount of load that can be transferred through a joint, how we can calculate? It is nothing but the strength of the joint, right? The minimum of strength of the bolt or strength of the joint. Because if the bolt will fail, then the joint will fail in, bolt failure. Like in bolted connection we have seen that failure may occur or may come due to the bolts, the failure of bolts or the failure of the plates. That's all. Say, like, next question what he said. Yeah, welding is a process. It is done with or without pressure. Okay, we can do it with or without pressure. There are different kind of welds are there. So that's it. And one more thing here, for this condition, like we have some interaction formulas for shear tension, for shear moment, and also so these interaction formulas are also important, very important. Like here for shear and tension connection, for shear and tension connection, the combined condition, that means the interaction formula of IS 800 clause 10.4.6, that means your option D, VSF by VDF, that means induced shear stress divided by design shear stress, or induced shear capacity and design shear capacity plus that induced tension and design tension capacity, that should be less than 1. One more thing we have for moment and shear also, like I think I have added this here. You can see the combined shear and tension formula. So this thing is also important. It's nothing but the induced part divided by the design capacity, induced tension, design capacity, and that should be, the combination should be within 1. It's the upper bound of this is 1. So now, onwards there are similar kind of questions. So what I will do, I will upload this entire questions to that folder and also this video. So if you have any doubts, you can ask me, because it's a short session and it will continue up to 10:30, and I've reached 10:30. So if you have any questions, you can ask me. Otherwise, we will, end this session, and I will upload this video and that particular material to that folder. So Sivraj, do you have any questions regarding the exam? You can ask me. No problem. Okay, okay. Sir, 40 question MCQ, then what about 20? That means for other 20 you have to type one. Yeah, you have to type for certain percentage of questions, but not for all that 20. There might be MSQ type question, like numerical values will be provided and you just need to select. But yeah, there should be some questions where you need to put the answer. So you should be careful about what should be the range, because the deviation, one deviation should be there, and the deviation uh, you shouldn't go beyond that. That's why I specifically told you that read the question up to which decimal places you need to consider that answer and all these things. So there will be some type of questions where you need to put your answers, and mostly that question will be 3 marks or 4 marks questions. Okay. Okay, so Teja, you are there. So do you have any questions? You can ask me. And Sivraj, I will suggest that go through all the assignments. Okay, 2022 and 23, and so that's it. Um, you can attend all the questions. Okay, and don't think about the codes and all these things. All the values will be provided. Some of the essential things, like this crucial part of this, like one that particularly when you need to solve that built up member, there are lacing and batten, some specification regarding the lacing and batten. What should be the thicknesses, what should be the sizes, what should be the angle, what should be the that radius of gyration. All these things you go through it. So short type of questions may come from there. Okay. Okay, then if you don't have any kind of questions, then I can conclude the session here. Best of luck for your exam. Yeah, don't worry, be cool and patience. Yes, you please share your email. Yeah, you can reach out to me via this mail, and I am very much active to that. Like my IT Gmail ID here, p.devasis@itg.ac.in. You can reach out to me by this mail. Okay, no problem. Yeah, no problem. No problem. Yeah. So, okay, third year BTech student. Okay. So, yeah, no problem. Actually, some of the video lectures are also there in that particular YouTube file, YouTube folder. So, before joining that PhD, I worked under MHRD as a TechU faculty. So, yeah, if you have any kind of doubts regarding design of steel structure, any kind of software things, you and all of the students can reach out to me. Okay, no problem, and I will be happy to help you. Okay. Okay, then uh best of luck and happy Durga Puja. Yes, sir. So you have exam, so you need to study, so study. Don't take that much of pressure. The question will be easy. Okay. I think you can see the pattern also, right? Okay. So thank you. Yeah, I'm ending the session.